Hello everyone, welcome to our channel OnlyPhysics JEE Grad. So in this video we'll be discussing JEE Advanced PYQs from the chapter Work, Power, Energy. This will be the second video on this chapter and the topics we'll be discussing kinetic energy, potential energy, conservation of energy continued because in the last video the first topic we have discussed about is work done by constant and variable force. There were 8 questions we have discussed. In the same video, the second topic which was on kinetic energy, potential energy, and conservation of energy. There were 21 questions, but we have only discussed not 9, we have only discussed 8 questions. So we are left with 13 questions from this. Okay. And the second topic of this video will be power. So there were only 5 questions. We'll be discussing all of them. So in total, we'll be discussing 18 question in this video. So let us start with our first question. So let me just get the questions for you guys. Okay, perfect. So this is our first question, right? So in this question, it is asking work done of the mass by a force. So this is our force, okay? When the particle is taken from a comma 0 to 0 comma a along the path, circular path of radius a about the origin in xy plane. Okay. So actually this question is based on a variable force, okay? So let's solve it. So work done is we know fx dx plus fy dy. Okay, I'm not writing fz dz because the particle is moving in xy plane only. So work done will be integration. What is fx dx? So it will be x dx divided by x square plus y square to the power 3 by 2 plus it will be y dy upon x square plus y square to the power 3 by 2, right? Now this question is again based on, like, we have to consider, like, we cannot integrate it because x and y are both variable. So how will we integrate? So we have to assume something. So and then we have to do partial differentiation and then substitute it. So let's solve. So let's say this is, look, x dx and y dy, and the denominator is same. So we'll consider x square plus y square as t square. So we will have 2x dx plus 2y dy equal to 2t dt, right? So we'll have x dx plus y dy is equals to t dt, right? So let's substitute this. Consider this. So let's substitute this. So x dy, x dx, y dy, and t dt will be t dt divided by x square plus y square is t square. So t square to the power 3 by 2, 2 will get cancelled. So simply it will be t cube. Now we have dt upon t square. So we will get t to the power minus 1 upon minus 1. Now let's substitute back the value of t. It will be so it will be minus 1 by t, right? Now let's substitute it. So work done will be minus 1 by under root x square plus y square because it's t square, right? So it will be under root. Now where we are taking it from a point a comma 0 to 0 comma a, simple, right? So minus will go out. Let's first put this. So it will be 1 by a minus 1 by a. So it will be 0. So work done by this force will be 0. Okay, so clearly we have done the integration, so we do not actually need the path, right? So answer will be D. So this question is actually uh, based on the topic work done by variable force, right? No worries. Let's move on to our second question. So this will be our second question. So this is a question based on matching list. So it's half, I think. Yes. So let me bring the other part. Right. So this is our question. Now let's study. We have a particle of unit mass. We have a particle of unit mass moving along x-axis under the influence of a force, and its total energy is conserved. So we have total energy is constant, right? Four possible forms of potential energy are given in column 1. Okay, so we have U here. Match the potential energies in the column 1 to the corresponding statements in the column 2. Okay, so we have certain statements. Okay, so first statement is force acting 0, force acting 0, and force acting 0. So we for in the first three, we are talking about the force 0. Where are these forces? Okay. In the second, the particle experience an attractive force towards x equal to 0 in the region minus a to a. So it's mod a less than a. So it will be x less than a greater than minus a, right? Okay. So again, it is talking about the direction of force itself. And in this, con we have to consider the particle with total energy u naught by 4, which can oscillate about point x equal to minus a. So we are talking about something like equilibrium here. Okay. So to solve this type of question, first find force. Okay. First find force and then draw the graph of u versus x, and the situation will be very easy. Okay. So let's start to solve this, and you know u versus x graph. So this is u, this is x. Let's say we have like this. Okay. So in this the concave region, it shows at this point, at this, let's say it is x equals to a, this is x equal to b, and these are other points. Okay. So it's let's say x equal to c. So x equal to a, it is stable equilibrium, right? Stable equilibrium. X equal to b, it is a convex region, so it will be unstable equilibrium, right? We have studied this. And x equal to c and any point where there is a flat line. Flat line means the flat line which is parallel to horizontal, so we have neutral equilibrium, right? And we have also studied that to understand the question easily, just consider this as a path of the particle. Let's say we have put the particle here. It will move like this. So it will try to go like this. Means what is happening is the force is acting in this direction. If I put particle here, then force will acting in this direction. So in stable equilibrium, force will act towards the minima. Okay. Here, if I put particle here, it will just slide down, right? It is not actually, remember, it is not actually the path of the particle. This is a graph. But if you consider it as a path, the situation will be easy for you, okay? So if I put particle here, then particle will go like this in this, right? So what will happen that if I put particle on the right side, the force will act on the right side. And if I put particle here, the force will act in this direction. So look, from this u versus x graph, we can find if it is a stable or unstable equilibrium, and also we can find where the force is acting, right? And from this graph also we can also find that here the slope is 0, and slope of u versus x will give us force itself. So we can also find where the force is 0. So clearly what we have to draw is the u versus x graph in all the situation. But to draw this graph, we need to know about the minima and maxima. So we need to find the force also. Okay, if you get force, what is force? It is du by dx, right? And then put it to 0. So we'll have minima and maxima, and then the graph will be simple, right? So it's a not it is not a physics question, it is more of a mathematics question. So let's start to solve. So let's say first A. So we have U equals to U naught by 2. So it's a pretty lengthy question. X by A square whole square. Right? Let's differentiate it. We know f is minus du by dx. So minus will come U naught by 2. Let's use the chain rule. So it will be 2 1 minus x square by a square, and then chain rule inside it will be minus 2x by a square. Okay, so we have this will get cancelled, minus minus will be plus, so we'll have u naught 2 will also be there, x divided by a square 1 minus x square by a square. So this is our force. Now if I want to know minima and maxima, we have to put f as 0. So if you put 0, then x, if x is 0, f0, so f is 0 at x equal to 0, at x equal to a, and x equal to minus. Because if you put a here, this will 0. It will, if you put minus a here, it will also 0. So in these points, we have force 0. Now, the graph will be very easy to draw. Let's try u versus x. Okay. As soon as you draw this graph, the picture will be very clear. So we have these 3 points. This is x equals to 0, right? Now, if I put x equal to 0, we will have u naught by 2. The potential energy will be u naught by 2. So this is u naught by 2. Okay. If I put x equal to a, so it will be a by a1, and this will be 0. So here will be 0. Now, if I put x infinity, so it will be minus of infinity. So the graph will be going at x infinity, it will be going u is minus infinity, right? So it will be going here. Okay, it will be going here. And if I put x minus infinity, so it will be plus, but 1 minus of infinity, it will be minus infinity, so it will be like this. So let's draw the graph. So look here at x equals to a, right? At x equals to a, we have a minimum, right? We have a, so at x equals to a, force is 0, right? And x equals to a, if I put u will be 0, so this is a point, this is also a point. So graph will be like this. So uh, let's study it again. If I put x as infinity, it will be minus infinity to the square. Okay, so graph will be here, right? Okay, so it will not go here at x tends to infinity. So it will go at x tends to infinity, it will go positive. Now the graph will come. So graph will be like this. Okay, so clearly we can see here it is a stable equilibrium. This is also stable equilibrium. Okay, but here it will be unstable equilibrium. This is unstable. Okay, perfect. Now we'll get the all the answer. So first, the force acting on the particle is 0 at x equals to 0, right? At x equal to 0, force is also 0. At x equal to minus 8 is 0, right? So PQR will be the options. The particle experience an attractive force towards x equal to 0 for this. Okay, so look, if I put particle here between a to minus a, if I put it here, the force will be acting here. If I put it here, the force will be acting here. I told you, consider it as a slope, as a path of the particle. So if you put the particle here, it will go like this. So the force will never be in the, so force will be in this direction. right? If I put particle here, the force will be this direction, will not be. So S will be, S will not be. So we will have P, Q, R, T. For the particle with the total energy U naught by 4 can oscillate about x equal to minus A. Now, to solve this, okay, first understand this. What is this? Now it is saying if a particle's total energy is U naught by 4, okay, so total energy is potential energy plus kinetic energy, okay, then it will oscillate about x equal to minus A. Now think U naught by 4 as 100, okay, so we have a particle whose total energy is 100. Now if you get that, look at this point, right, it's a stable equilibrium and this is a equilibrium point. So at equilibrium we know potential energy is minimum, and at other point potential energy is going to increase, is going to increase, we know that, right? Perfect. So if potential energy is going to increase, we just need to check the potential energy where is it is minimum. So look, if the potential energy at that point will become 200, let's say, then can we have any kinetic energy? Then kinetic energy will be, it will be minus 100. Is kinetic energy minus 100 possible? No. So we do not have this particle oscillate about x equal to minus A if it is total energy is u naught by 4, right? For other cases it will be fine, but this situation is should not be like that. Okay, now let's start at x equal to minus A. So this is our uh, equilibrium point, right? At here potential energy is 0, so u at x equals to minus A is 0. If it is 0, if you put it 0, then kinetic energy will be positive. So yes, this will be the case. And now why it will oscillate? Because this is a stable equilibrium. Particle will always oscillate about the stable equilibrium. So we will have T as also our answer. So for A part, we will have P, Q, R. Let me change the color of pen. So we will have P, Q, R, and T. Okay, let's move on to option B. So it will be U naught by 2 x square by a square. Let me write it here. B. So we have U as U naught by 2 x square by a square. So let's differentiate it, minus du by dx. So it will be minus U naught by 2 into 2x by a square. So we will have f u naught by 2a, so 2 will get cancelled. 2 will get cancelled. We have u naught by a square to minus of x. So this is a simple SHM equation of SHM. So we know. So force is 0, F is 0 at x equals to 0. Okay. So P will not come, Q will be the one option, right? Q will be the one option. So here will be P, Q, R, and T. So here Q will be the option. P and R won't be there. Now let's just make the graph here. U versus X. Okay. So this graph will be very simple. It says X square. So here it will be 0. This is A. The graph will like this, right? This will be U naught by T, right? At X equals to minus A and X equal to plus A. Okay. So on this point, X equal to 0, it is the point of stable equilibrium, right? So the particle experience an attractive force towards x equal to 0 in the region right, right. If you put particle here, it will try to go there. Particle here, it will try to. So force will mean to always towards the x equal to 0, right? So S will also be the option. Now T. The particle with total energy U naught by 4 can oscillate about the point x equal to minus a. So at x equal to minus a, there is no equilibrium. So this option won't be there. So A and B is clear. Now, so these were our two parts of the column 1. Let's move to the third part. So we have the third part as this. So we have u equal to, this is our C part, right? U naught by 2 x by a to the whole square, right? Into e to the power minus x square by a square. Okay, it's going to be complicated, I think. So force will be minus du by dx. It will be minus, so u naught by 2a square is constant. We are left with, so let's differentiate it. It will be 2x e to the power minus x square by a square plus x square. Differentiation of exponential will be same, but we have to use the chain rule. It will be minus 2x upon a square. Okay, so force will be, so the things which are common we can take it out. So 2 will get cancelled. Okay, so it's minus u naught by a square. We can take x and e to the power minus x square by a square as common. Okay, so we are left with 1. This is minus, this is x square by a square, right? So again, it is the same situation where f equal to 0 will be at x equal to 0, a and minus a. Okay, so p q r will be the option for that. P, Q, and R. Let's check S. So we have to make the graph for all those three. So let's make the graph of U versus X. It's easy, right? U versus X. Okay. Now at X equals to 0, U will be 0. So we have this point. Now let's say this is X equal to A and this is X equals to minus A. Now look, if I put X infinity, so this is infinity and this is exponential to the infinity. So it will be like this. So it is like x square upon e to the power x square. If I put x infinity, so exponentials infinity is much larger. So eventually this term will go to 0. So this graph will be going to 0. Similarly, at minus infinity, it will be going to 0, go to towards 0. Okay. Now, if I put x equal to a, if I put x equal to a, so we have u naught by 2, this will get cancelled, and e to the power minus 1. So at x equals to a or x equal to minus a, we have u as u naught by 2 e to the power minus 1. So let's say it is somewhere here. This is our point, u naught by 2 e to the power minus 1. So here we will have this and here we will have this. So graph will be like something like this. Okay. So this will be the graph. It is going like this. Right? So clearly we can see at x equal to 0, this is stable, this is unstable, and this is also unstable. Okay. For x equal to 0, yes, if you put particle here, force will be in this direction. If you put particle here, force will be in this direction because it is going like this. So force will be in this direction, right? So S will be our option. S will be our option for the part C, right? Okay. Uh, yes. So S will be the option. Now we have to check T option. So at x equals to minus a, x equals to minus a. So s equals to minus a is unstable equilibrium. If you put particle here or in the right side, it will go like this. And if you put here, it will go like this. So t will not be there. Okay. So this marks an end to our part C. So it's a quite lengthy part. Let's move on to D. So D will have, so D, we have u naught by 2x uh, x by a minus x by a minus 1 by 3 x cube by a cube. Okay, so let's first find force. It will be u naught by 2, 1 by a minus, and 3 will come here, 3 will get cancelled, so it will be x square by a cube. Okay, so we can also take a as common, so we have 1 by x square by a square. So clearly we again have force 0 at x equals to a and x equals to minus a. Okay, so which option will be there? Q will not be there, so P and R. So P R. Now let's, for S and T, we have to make the graph of U versus X. So let's make the graph of U versus X. So this is X, this is U. Okay. Now here X equals to A, this is X equal to 0, this is X equals to minus A. Okay. Now if I put x0, so u will be 0. If I put x equals to a, then we will have u as u naught by 2, 1 minus, so a, it will be minus 1 or minus 1 by 3, so it will be have u naught by 3. So this u naught by 3, right? And if I put minus 1, so it will be minus u naught by 3, right? Look, the at x equal to n minus a, slope will be 0, right? Because force is 0. Now if I put x infinity, so infinity to the cube is more negative, so it will be negative. So f as x infinity, you will go here, right? You will go in the downside, not here. And for x minus infinity, you will go here. So we'll have graph like this, right? So slope here and here is 0, right? Perfect. So we have to check at for between x minus a and a, as the force is always in the x equal to 0. Let's check. If you put particle here, it will go like this, so force indeed in this direction. But if you put particle here, particle will go like this, so force will be in this direction, right? So it is not always in the direction of x equal to 0, so s will not be there. Let's check t. For t at x equal to minus a, first there must be a stable equilibrium, and the total energy is u naught by 4. So let's check. Now, yes, x equal to minus a is actually a stable equilibrium, and at this point u at x equals to minus a is minus u naught by 3. So if you put total energy is equals to potential energy plus kinetic energy, and we have total energy as u naught by 4, and this is minus u naught by 3 plus kinetic energy. So we will have kinetic energy will be positive, right? Which is fine, which is fine. So hence it will oscillate about x equal to minus a. So for that, option D will be correct. So we have P, R, and K. So this is a very lengthy question. It took like 25 minutes, I must say. But this question is actually worth it. Okay, it's worth it to solve. Let's move on to our third question. Yes. So we have this. I think this is incomplete. Let me complete this. Right. Perfect. So we have a student skates up a ramp. It's like this, going like this at an angle 30 degrees. He start at the bottom of the ramp with the V naught. So here it is having a speed V naught. He wants to turn on the semicircle XYZ of radius R this. So this is a during reach a maximum at H. So here we'll be reaching at maximum at point Y from the ground. Assume that energy losses force required for this turn at the highest point is provided by the weight only. So at this point, let's say it has a speed v. So at this point it has a speed v, and here force will be acting in mg sine theta, which will be giving the centripetal force. So clearly we have mg sine theta is equals to mv square by r, right? So at y, velocity will be root rg sine theta, which will be root rg sine theta is 1 by 2 because theta is 30 degree, right? Perfect. So this is velocity at y. Okay. Now, then, so this must be from energy equation. So let's write. So let's say this is a and this is y. So we write energy conservation. So total energy at a equal to total energy at y. Or simply we can write work energy theorem. So we will have work done is equals to half m final is half mv square minus half m v naught square. It will be only h height will it achieve, so it will be minus mgh. Okay, only the uh, gravitational force will do the work. So it will be half m vy. This is y, right? It will be rg 1 by 2 minus half m v naught square. So m will get cancelled, and if you multiply 2 here, so we'll have minus 2gh equals to rg by 2 minus v naught square. So we will have v naught square minus 2gh equals to rg by 2, right? So this is our A option, right? So at this point, this is interesting, okay? So the weight will be mg sine theta, and it will be equal to our centripetal force or centrifugal force to be precise, right? So this is wrong. The centripetal force required at point x and z is 0. No, look here, there will be velocity, right? And we know as it is going upward, the kinetic energy will decrease because it will be converting into potential energy. So at point vx will be more than vy, right? So centripetal force can never be 0. The centripetal force required is maximum at points x and z, right? Because after that the velocity will keep on decreasing, and then after y it will keep on increasing. So yes, this option is correct. Okay, so this is a quite easy question, but this line was very important. The force required for this turn at the highest point is provided by weight only. So this was very crucial. Okay, let's move on to our fourth question. So we have fourth question. This, right. So we have a small ball starts moving from A over a fixed track as shown in the figure. The surface AB has friction. So this is a friction. This has a friction. And A to B ball roll down without slipping. So if it is rolling down, it's like this. Okay. So if it's starting with 0, so here kinetic energy is 0, right? This is A point. This is B. And this is C. So at B, mgh will be converted to the rotational energy as well as kinetic energy because it is rolling. So here we have kinetic energy as half I omega square plus half m v square, where v is equals to omega r. Okay, now the surface BC is frictionless. So if it is frictionless, then it will keep on rotating with omega, but this velocity will decrease. So at C, what will happen? Kinetic energy will be half I omega square. Okay, and look, if this is H A, if this is HA and this is HC. So HC will be always less than HA. Why? Because this kinetic energy is given by mgha. From this total kinetic energy, only half mv square is converted back to mghc, right? So as mghc is less than mgha, so hc must be less than ha. Okay, so option C will be incorrect, and option D, HA is less than HC, is again incorrect. Now we have to check A and B. So A is saying HA is greater than HC, right? KB will be greater than KC. So KB will be greater than KC, right? Correct. Because at KB, this is kinetic energy at B is half I omega square plus half mv square. But at KC, kinetic energy at C is half I omega square only. Okay, so this is correct. Now B, HA is greater than HC, right? But KC is greater than KA. So yes, it is starting with zero kinetic energy, and at C it will have half I omega square. So this is also correct. Okay. So again, it was very easy question. Let's move on to fifth. So we have our fifth question right here. Okay. So what is given in this question? A particle is acted upon a force of constant magnitude. So F is constant. The magnitude is constant. Okay. It is always perpendicular to the velocity. So this is like a circular motion. Okay. So if V is here, force is always in perpendicular direction, right? So definitely it is talking about circular motion. The motion of the particle takes place in the plane. We know its velocity is constant. No, velocity is not constant. Direction is changing. Speed is constant. Acceleration is constant. No, because the direction of force is changing again. Kinetic energy is constant. Yes, as speed is constant. So kinetic energy is what? Half mv square. So it is also constant. So this is correct. It's moving. It moves in circular path. This is also we knew that it is talking about. This question is talking about circular motion itself. Let's move on to our next question, sixth. Right. So what we have here is consider an elliptical shaped rail PQ in a vertical plane. Okay, vertical plane. So G will be there, right? OP is 3, OQ is 4, so this is 5, right? Pythagorean triplets. The block 1 kg is pulled along the rail PQ with a force 18 Newton, which is always parallel to PQ. So we have this PQ and the block is moving like this, but force is always in this direction. So we can simplify the work done by this force will be F into displacement. So what is force? 18 and displacement is 5. So work done by this force will be how much? 90 Newton. Right, we can directly find this. Assuming no friction losses, the kinetic energy of the block when it reaches Q is N into 10. Okay, so look, this work done is positive. Okay, work done by gravity is negative, and uh, the final kinetic energy will be, so it is starting from zero, right? Okay, so kinetic. So we'll just write work done is equals to change in kinetic energy. So final kinetic energy is half mv square. Initially it was zero. We're starting from rest. Nothing is given, so we'll consider it. So we'll consider it as rest. Okay. Work done by gravity will be mg4 because 4 is the height plus work done by this force. Okay. So we will have minus mass is 1, g is 10, and it is 4 plus work done by force is 90 is equals to half mass is 1 into v square. So we have to find the kinetic energy, right? So just let it be kinetic energy. So we have kinetic energy as 90 minus 40 is equals to 50, which is n into 10. So n will be 5. Yes, this is a quite easy question we have here. Okay, Let's move on to question number 7. So we have our 7th question right here. Now, in this question, it is given a block of mass 0.18 kg is attached to the spring. Okay, the coefficient is this initially broke at rest. The spring is unstretched. The impulse is given such that the block slides a distance 0.06. Okay, perfect. So look, if block is here and it is sliding a distance 0.06. So spring will store energy half kx square, right? And also friction will be losing the energy. Okay, perfect. For the first time, so it will comes to the rest. So initially it may have some energy which will be lost by friction and some energy will be stored by spring. So initial energy, okay. So let's say it as initial energy V naught, final energy is 0. So we'll use work done equal to change in kinetic energy. So 0 minus half m V naught square. Now friction will lose energy, so friction into displacement x. Now x is this same, okay, minus half k x square, right? This is work done by spring. So we will have minus. First, let's find friction. So friction will be mu mg. So mu is 0 0.1, m is 0.18, and g is, let's take it as 10. So it will be 0.18 Newton. So we'll write 0.18 into 0.06 minus half. K is 2 into 0.06 to the whole square is equals to minus half. Mass is 0.18 into V naught square. Okay. Okay, perfect. So this will get cancelled. Minus get cancel. We can take 0.06 common. So we'll have 0.18 plus 0.06 is equals to, it will be 0.09. Okay, V naught square. Perfect. So we have 0.06 into, this will be 0.24 divided by 0.09 is equals to V naught square. Hmm. So we have V naught equals to under root. The 0 will get cancelled. This is 2. This is 3. This will be 0.8. So we have 0.08. So we have 0.16. It will be 0.4, right? Which is n by 10. So we have n as 4, right? So this is an easy question. So look, the questions from work energy are quite easy. Huh? So you should not leave any question. Let's move on to our 8th question. Right. So what we have here is a spherical ball of mass m is kept at the highest point in the space between the two fixed concentric sphere A and B. The smaller sphere A has a radius r and the space between the two sphere has a width d. So this is d and this has a radius r. Okay, so question is incomplete. Let me put the other half of the question. Right. So what else is given? The ball has a diameter very slightly less than d. Okay, so as soon as it leave the contact from the base, it will come in the contact with the sphere B. Okay, all the spheres are frictionless. The ball is given a gentle push. The angle made by the radius vector of ball with the upward vertical is denoted by theta. Okay, So express the total normal reaction force exerted by the sphere on the wall as a function of theta, and let the N and B magnitude of normal reaction exerted by NB. Sketch the variation of Na and B with the cos theta. Okay, so we know this, right? This is our one sphere, this is our another sphere, right? So this will start to move here, and at an angle theta it will reaches here, right? And let's say it leave the contact here. So what will be the theta? We remember this cos theta turns out to be cos inverse 2 by 3. If you remember, you should learn this. And as soon as it leave the contact, it will come in contact with the sphere B here, and then normal will acting in the downward direction. Okay. So let's make both the situation individually. First, it is in the contact with the sphere A. So we will have mg here. This is theta. So this will be theta. Normal will be here. And here we have mg cos theta. And here it will be mg sine theta. So what we can write is, mm, yes, so mg cos theta minus normal will be equals to mv square by r, right? So look, d is very small, so I'm just taking r. In the second case, I will not take r plus t. Okay. Now let's use the work energy theorem. So look, this is r, so this distance will be, right? So if in this region here, so this is r cos theta, and this will be r minus r cos theta, right? Right. Now the particle went downwards. The distance by which the particle went in the downward direction is r minus r cos theta. So we will write work done is equals to change in kinetic energy. Initially it is 0, finally it is v. So we will write minus mg r minus r cos theta will be equal to, initial final is half m v square, right, minus 0. So we have in this direction is, so it will be plus, will be plus. Potential energy is decreasing, right? So it will be plus. Okay. So m will get cancelled. So we have v square is equals to 2 gr 1 minus cos theta, right? Okay. So let's put it here. Let's put v square here. So we will have mg cos theta minus normal equals to m by r 2gr 1 minus cos theta. So r will get cancelled. Normal will have mg cos theta, and this will come here minus 2mg 1 minus cos theta. Okay. So what will we have? Normal will be minus 2mg, and this will be plus 3mg. This 2mg cos theta, and this will be, so we'll have 3mg cos theta minus 2mg. So normal will be simply mg 3 cos theta minus 2, right? And we know if I'm just writing it in as an extra. So if normal is 0 means it is losing the contact with the sphere A. So cos theta will be 2 by 3. So theta will be cos inverse 2 by 3, right? We have done that. We have studied this. So, okay, perfect. So this was for the sphere A. Now for the sphere B, what will happen? Normal will be here, mg cos theta will be here, and mg sin theta will be here. Right? So we will have n plus mg cos theta will be equal to mv square by r. And now look, v square will be the same. So we'll put it here, v m 2gr 1 minus cos theta divided by r minus mg cos theta. So r will get cancelled. So we will have 2mg minus 2mg cos theta minus mg cos theta. So we will have 2mg. So just we can take mg common, right? So we'll have mg 2 minus 3 cos theta. Okay. Now this is normal due to A and this will be normal due to B. Okay. So write it as perfect. So look, the theta here is should be greater than equal to 0 and less than cos inverse 2 by 3. And here theta should be greater than equal to cos inverse 2 by 3 and less than, okay, because we are talking about less than equal to. So we have in the question, we have to take the theta from 0 to pi. Now this is our relation. Second, we have to make the Na versus cos theta. So if this is normal, this is cos theta, so we can write Na as a y equal to mg 3x minus 2, right? So if I put cos theta 0, okay, so first understand this, if theta is 0, if theta is 0, then cos theta will be 1, okay, and for this, so cos inverse, let me use the calculator. So cos inverse 2 by 3 will be, so if theta is cos inverse 2 by 3, right? So this theta is approximately 48 degrees, okay? So theta is approximately 48 degrees. So cos theta is what? 2 by 3, right? So we are talking about 0 to 48. So cos theta will be 1 to 2 by 3. So let's say cos theta is 1 here. This is 2 by 3. Okay. So we are talking about 2 by 3 to 1. So if theta is 48 degree, then this will be 0. So we have this point. And as theta increases, what will happen? Let's say theta is 0 degree. So we'll have 1. So we'll have mg. So no, normal will be mg. And this is a straight line equation, so we'll have this, and this is mg. Okay, now for the second, this was na. For the second, cos theta, and we have nb. Now here theta is from 48 degree to 180 degrees, and if I take theta as 180 degree, then cos will be -1. So this will be -1, and this is our 48 degree. So 2 by 3, right? So let me rub this cos theta. Hmm, this is -1. This is 2 by 3. Okay. So at 2 by 3, cos theta at 2 by 3, and b will be 0. So we have this point, and at -1, so it will be 5 mg. So it will be this 5 mg. We have this point, and we'll join this. Okay, perfect. And this point we can also calculate. Here cos theta is 0. So cos theta is 0. So this point will be 2 mg. Okay, so these are the two graphs. So it's a quite interesting question, of course. If you haven't studied this, it will be like real difficult to solve. But I will put it in the model. So it's a bit nice question. Let's move on to our ninth question. Let's move on to our ninth question. So here we have our ninth question. Now we have a string with one end fixed on the rigid wall here and passing over the fixed frictionless pulley at a distance 2 meter. So this distance is 2 meter, okay, from the wall, from the and has a point mass this attached to it the distance 1 meter. So this is 1, okay, from the wall. A mass m 0.5 kg attached at a free end here is held rest so that the string is horizontal between the wall, pulley, and vertical. So initial situation is like this. Okay, this is small m, this is capital M. This is 2 meter, and this I don't know. Let's say it is x. I don't know. Oh, we should not like write it like this. So let's say it is any distance. Okay, now the situation is at rest. What will be the speed with which the mass m will hit the wall when the mass m is released? So if I release it, it will go like this, and this will hit like this, right? So this is our initial situation. This is our initial, and final will be like this. So this string is attached to it. The block will go here, okay, and from here it is like this, and this pulley was fixed. The mass will go here. Okay, so this is theta, and it will hit with the velocity v. We have to find this v. This v we have to find. Okay, so look, the problem is we can't take it as initial because we need a equilibrium where the whole system is at rest. So this situation is our equilibrium, right? So let's take this as our initial. Okay. So what was that? Initially, the particle was here, and this, if this is going like this distance is more, right? Initially, this was 1 meter, and this was 1 meter. Now this becomes 1 meter. So this is 2, this is 1, this is root 5. So clearly this length is this length. Initially it was 1 meter, now it is stretched to root 5. So this particle initially, let's suppose it was here. Now it is going up at the distance root 5 minus 1. Are you getting me? Are you getting me? So initially it was here. Okay. Now what happens is this object is going like this, and this become root 5. So initially it was 1, now it is root 5. So the change in the distance between the string is root 5 minus 1. So this block must have gone up by a distance root 5 minus 1, right? So let's study. So if this is our initial, this is our initial. Now what is happening? Let's say at this potential energy is 0. So we will write initial equals to final, right? We're using conservation of energy. So initially u0, right? So initially for this particle it is 0 plus. For this it is at a distance. Uh, if I solve like this, let us say we just write the change. Okay, so we'll just write the change. So we'll use work done is equal to change in kinetic energy. Okay, so initially all everything is rest. Final, let's suppose it has v dash speed, so we will have half small m v dash square plus half capital M v square. So this is small m and this is capital M. Okay, minus 0. Initially they were at rest. Now work done. So it has gone up with root 5 minus 1. So what we'll write? We will write minus mg root 5 minus 1. Okay. Perfect. Now this object has gone down by 1 meter. So we'll write plus mg, capital mg into 1. Okay. That's it. Now we have to solve this. But the problem is we don't know about v and v dash. Okay. So look, this is v is going upward. So along this length, this must be v dash. And if this is theta, so this must be theta. This must be theta. Okay. So so now this is v, this is v dash. So we will have v dash cos theta as v. So we'll write v is equals to v dash cos theta, right? So we have to put this. Now cos theta we can find it will be 2 by root 5. Okay, so it will be 2 by root 5. So if we want to find v, then we have to put v dash as v upon cos theta. So we will put v dash as v upon cos theta. Right? So let's solve. Small m is 0.5, so it will be 0.5 minus into 10. This will be root 5 minus 1. The calculation will be typical. Capital M is 2 into 10 is equals to half. Small m is 0.5 into v dash will be v square by cos square theta plus half. Capital M is 2 and v square will be v square. This will get cancelled. So we have v square. So cos theta will be 2 by root 5. So cos square theta will be 4 by 5. So let 4 and 5 will come up. So we'll have half into 0.5, 5 divided by 4. Right? Plus this is v square, this is v square. Now this let 5 root 5, and so let's just solve the bracket also. So this will get cancelled. So we'll have minus 5 root 5 plus 5 plus 20. So we will have 25 minus 5 root 5 will be equal to, so let me rub this. So it will be 25 minus 5 root 5 will be equal to, now this is 25 by 80. So 25 by 80 v square plus v square. Yes, 25 by 4, 8, right. So this will be 105 v square by 80. So this will be 25 minus 5 root 5. So I will use the calculator. So 25 minus 5 root 5. And I have to multiply it by 80 and then divide it by 105. So we will be having v square as 10.52. Okay, 53 we can take. So we'll have v as under root 10.53. So it will be approximately 3.245 meter per second. So this will be the answer. Okay, approximately I have taken G as 10. You can take it as a 9.8 and you will get the answer. So this is our answer. So again, it is a moderate question. The question is actually easy, but the calculation is lengthy, right? So let's move on to our question number 10. Let's move on to our question number 10. So this we have. Okay. So this is a quite easy question, I think. Block moves from a point A in a horizontal with a speed 3 meter per second. The original length is 1 meter. Okay. The force constant is 2 Newton per meter. The part AB is frictionless, so it's frictionless. And the part BC has a coefficient static and kinetic. Actually, we do not need to use static, right? So this is 2, this is 2.14. So BD is 2.14. Find the total distance through which block moves. So we have to add 2, 2.4 and the x. Okay. So let's solve this. So look, from B to D, right? So friction is acting. Okay. And after D, friction is also acting. So for the total length, friction is acting for x plus 2.14, right? So this is x. Now what is happening is, if x, it presses the spring by distance x. It presses the spring by distance x. So it will store the energy as half kx square. So just let's write work done equals to change in kinetic energy. Okay. So final kinetic energy is 0 minus half m. Initial kinetic energy was 3. So we'll write just V naught square. So V naught was 3 meter per second. Okay. Now work done by friction. It will be minus friction into x plus 2.14 and minus half k x square. This is the work done by spring force. Right? So friction we can find, friction will be mu mg. So mu is 0.2. Look, we have to take the kinetic, not static, because static force, static friction will never do work. M will be 0.5 and g will be 10. So this decimal will get cancelled and this will be simply 1. So we have minus 1 into x plus 2.14 minus half. K is 2 and x square equals to minus half. Mass is 5 by 10, which is 0.5 into V naught square is 9, right? Perfect. So we'll have this 2 will get cancelled. We'll have minus x minus 2.14 minus x square equals to minus, this is 4. So 9 by 4. So 9 by 4 is what? 9 by 4 is 2.25, right? 2.25. So we will have x square plus x, and this will come up here. So we have 2.25 minus 2.14. So we have 0.11. Okay, so we'll have minus 0.11 equals to 0. Right? So we'll use x equals to minus b plus minus under root b square minus minus plus 4ac, so 0.44 divided by 2. So we'll have minus 1 plus minus root 1.44 divided by 2. So this will be x equals to minus 1 plus minus 1.2, so 12 square, right? So x must be positive, so we have to take the plus 1. So x will be 1.2 minus 1 by 2, so it will be 0.2 by 2 will be 0.1 meter. Okay, right? So the total distance we have to find. So total distance will be 2 plus 2.14 plus 0.1. So answer will be 4.54. So answer will be 4.54. sorry, 4.24 meters. 4.211, right? So quite easy question again. The similar question we have just studied, right? So it's an easy again. Let's move on to the 11th question. So let's move on to our 11th question. Right. So we have two blocks and we are connected by such that the spring passes over this block B, slides over the stationary. So this is at rest. Okay. The block A slides along the vertical C both with same uniform speed. So they are moving with same uniform speed. The coefficient of friction between the surfaces, okay, is mu 0.2. The force constant is this. So K is given 1960 Newton per meter. So G we have to take as 9.8 meter per second square. Remember this. The mass of block is 2. So this MA is 2. So we have to find MB and kinetic, the potential energy in spring also we have to solve. Okay, perfect. So look, if they are moving with a constant velocity, uniform speed, right? So velocity is constant, right? So net force on them is zero. So let's make the free body diagram. On B we have a tension here and friction will be here. So friction FB, I should write it. So it will be FB. Let's write the free body diagram for A. So tension will be this in this direction. Okay, so there will be normal also, right? Normal of B, and here MBG, right? For this MAG. Now, as this is going in downward direction, so friction must be above, upward. So FA and normal will be here, right? Okay, let's first solve this. So NB will be MBG and FB will be tension, right? And I don't know MB, so let's just leave it like that. Now here in this direction there is only normal, so normal must be 0. Normal is 0, then FA is 0. So this is 0, this is 0. So we'll simply have tension as MAG, right? And MA I know it is 2 and G is 9.8. So tension will be 196. So 19.6 Newton. So tension is this, and we know tension is equals to Kx. So it is 119.6 is equals to 1960 to x. So x will be 1 by 100 meter. Simple. So potential energy stored in spring will be simply half k x square. So it will be half k 1960 into 1 by 1, 2, 3, 4. 1 0 will get cancelled. This is 98. So we have 98 millijoules, right? We'll have 98 millijoule. Okay. Now we have to find the mass of P. So look, FB is equals to tension, and tension we know, right? So look, FB is what? It will be mu MBG equal to tension is 19.6. So we will have mu is 0.2, right? 0.2 MB into 9.8 equal to 19.6. So this will be 2. So MB will be 2 upon 0.2. So it will be 10 kg. This will be answer. And here potential energy will be this answer. Okay. So it's an easy question again. Very easy, right? So mostly question from work energy will be extremely easy, right? You have to solve them. Let's move on to our next question. Okay, perfect. So this is our 12th question. The question here is we have a displacement of particle x moving in one dimension under the action of a constant force. So F is constant. Okay, is this. So we will have root x will be t minus 3. So we can write x as t minus 3 to whole square. So if I write v, it will be dx by dt. So it will be 2t minus 3. And if I again differentiate it, we will get 2. So this is constant. So yes, that implies force is constant. Right? It was correct. The displacement of particle when its velocity is 0. So velocity is 0. Velocity is 0 at t equal to 3. So if I put t equal to 3 here, we'll have x equal to 0. So displacement is 0, right? So displacement of the particle when velocity is 0, it will be x equal to 0. Displacement will be 0, right? The work done by the force in the first 6 seconds. Okay, work done by the force in the first 6 seconds. So there is only this force, so we can write work done by force is change in kinetic energy, right? So initially at t equal to 0, t equal to 0, velocity is what? Velocity is minus 6 meter per second. Okay, right? Now at t equal to 6 seconds, t equal to 6 seconds, velocity will be, so 6 minus 3, 3, 6 meter per second, right? So change in kinetic energy will be 0. So minus half m u square, so it will be 0, right? Because speed is same, right? Speed is 6, so work done is 0. So again, work done by the force will be 0, right? Now a tricky part is, in this we are saying the displacement of particle when its velocity is 0. So it is x equal to 0. Now my question is, there is a tricky part here. Look, at t equal to 0, the displacement is what? So it will be 9. X will be 9. Okay. Now at t equal to 3, right? 3 seconds. X is 0. So the net displacement from 0 to 3 is 9. Now we are saying the displacement of the particle when velocity is 0 is 0. So look, we are not talking about displacement. It is saying the position, actually, the position of the particle. So look, the displacement and position go hand in hand. They are like similar things. They depends on what is asking. So if it is asking find the displacement in first 3 seconds, then will be 9 will be the answer. Now it is saying the displacement when the velocity is 0. So it is actually talking about the position itself. So position is 0. Okay. So be careful. This is a very tricky part. Okay. Now let's move on to our last question of this topic. After that, we'll have 5 questions from power itself. Yeah, so this question is from power. Let me find the question which is left. So let's move on to our next question here. Perfect. So what we have here is a particle of mass m initially at rest at origin. So at t equal to 0, x0, v0. Okay. It is subjected to a force such that and start moving in x axis. The kinetic energy changes like this. So dk by dt is gamma t, and the gamma is some constant. So force, speed, distance. Okay. So look. So we'll find dk equal to gamma t dt, and we'll integrate it. So initially kinetic energy is 0 at t equal to 0. So at t equal to t, we'll have some kinetic energy k. So it will be k gamma t square by t, right? And we know the kinetic energy is what? Half mv square. So half mv square equal to gamma t square by 2. 2 will get cancelled. So we'll have v as gamma by m t square to the root. So we will write it as v equals to root gamma by m into t. Right? So if this is v, if I differentiate to find the acceleration, we will have root gamma by m, which is constant. So that implies force must be constant. So force applied on the particle is constant, right? Speed of the particle is proportional to t. Yes, it is proportional to t. The distance of the particle from the origin increasing linearly with the time. So let's see. So if I write dx by dt as a root gamma by m into t. So we will have dx equal to root gamma by m t dt. So it will not be linear, it will be parabolic, right? So we'll have x equals to root gamma by m t square by 2. So it will not be linear, so this is wrong. The force is conservative. Now the force, if F is constant, then it is conservative, right? So this is also correct. So it's an easy question. So this marks an end to our this topic, which is kinetic energy, potential energy, conservation of energy we have used here, right? Now let's move on to the second topic of this video, which is power. So there will be 5 questions. So this is our first question. Now, the wind power generator converts wind energy into electrical energy. Assume the generator converts a fixed fraction of energy intercepted by the blades into the electric energy. Wind speed is this. We have to find the electrical power output. So power is what? It is F dot V, right? Now, what will be the force? Look, if the wind is flowing like this, the wind is flowing like this with a constant speed of V, then it will be applying a force. How? Mass will change. So force will be m dv by dt plus v dm by dt. Now the velocity of wind is not changing, it's zero. So force applied by the wind will be v dm by dt. So mass will be changing, right? So wind keep on coming, so mass is changing. That is how the wind apply force on the blades. So we'll write just it as v dm by dt, and the velocity and change in mass will be in the force and the velocity will be in the same direction. So we'll just write it as cos 0. So this will be power will be dm by dt into v square, right? Now we have to solve this dm by dt. So we'll have mass as density into area into x, the length. Okay, so let's say this is the air column. It has area A and x is this, right? And the x is changing as v. So dx by dt is what? V. So let's just put it here. So we have d by dt rho ax into v square. Okay, so we'll have v square rho a and dx by dt is v. So we will have rho a v cube. So similar, so power is actually proportional to v cube. Okay, so C will be the answer, right? Now let's move on to second question. So it's a quite interesting question. We have solved this question in like foundation class 9th. Okay, we have mass m moving in a circle of constant radius. The centripetal acceleration is varying with time as this. So we have AC equals to k square r t square, and we know centripetal acceleration is v square by r equal to k square r t square. So we have v square equal to k square r square t square. So v will be k r t. The power delivered by the force acting on it. So force, let's first find the acceleration. So acceleration will be dv by dt. It will be constant kr, right? So force will be mass into acceleration. It will be k, so mkr, right? Mkr. So mkr, this is force. So simply power delivered will be F into V. So force is mkr into V is V square R square T square. So we will have M uh, force is mkr. So M, oh, this is K square, right? Okay, V is KRT. I have put V square here. It's KRT. So we'll have M K square R square into T power, right? So B will be the option. Quite easy questions. Let's move on to the third question. Yes. So we have, if a machine is lubricated with the oil, so what happens when you lubricate it with the oil? Yes, efficiency increases, right? Because because friction decreases, so the heat loss is reduced, right? Heat reduced. So mechanical advantage won't be there. Okay. Mechanical efficiency increase, right? Both no. Efficiency increases, but is mechanical no. Mechanical advantage is what? That I applied a force of 1 Newton and I am able to put a weight, say 20 Newton, 25 Newton. So this is a mechanical advantage. So mechanical advantage is weight which we are pulling divided by applied force. So this is called mechanical advantage. Yes, we have learned this in the kinematics video. There was a question from JEE Advanced, right? So B will be the option. Let's move on to our last second question. So power, work, these questions from these two chapters. These okay, the chapter is only one. So these chapter are quite easy, even if you consider from JEE Advanced perspective. Okay. Now a body moved along the straight line by a machine delivering constant power. So power is constant. The distance moved by the body in time t proportional to perfect. So if the power is constant, we can write for F into V is constant. Now we know F is what? M into A into V is constant. So we'll write this simply as, now we know A is what? dV by dt we will see. So we can write V dV integration is equals to C by M into dt, right? So we will have V square by 2 C by M into T. So we will have V as root 2 CM, and we can write dV as dx by dt, because we have to find the proportionality, the distance moved in proportion to t, right? So again we have to do integration. So dx will be root 2 cm t to the power 1 by 2 dt. Let's integrate. So we will have x, this is some constant k, and this will be t 3 by 2 divided by 3 by 2. So simply we'll get x proportional to t to the power 3 by 2. That's very easy. Okay, let's move on to our last question and we'll finish this video very fast. So we will have this question: a particle is of mass this is moving in one dimension, therefore there's a constant power. So power is constant, which is 0.5 watt, and mass is given 0.2 kg. If the initial speed is 0, so u is 0. Find the speed after 5 watt. So look, so power is what? dw by dt. 0.5. Now it is constant, so work done will be 0.5 into t. Now after 5 seconds, so if I put t5, total work done will be 0.5 into 5, which is 2.5 joules, right? And we know work done equal to change in kinetic energy. Initial was 0, so final is half mv square equal to work done was 2.5. So 2.5 into 2 divided by mass. Mass was 0.2. That's v square. So decimal will get cancelled. This is 2. So velocity will be 5 meter per second. Right? It's quite easy question. Okay. So this marks an end to our this video. We have discussed these two topics. Now the next video will be based on collision, no, work power energy. Okay. So let's finish the today's video. Thank you everyone.